All right, hello everyone.
Did you just tell everyone that?
Yeah, you need to go to the bathroom right now.
Thanks.
All right, so up on deck we have Taha and then Thomas Fan. So if you two could come up here. Taha, Thomas. Okay. And yeah, take it away, David.
Great. Well, I'm sorry that Paul had to go to the bathroom because I really wanted to give him the bird. I'm going to make a bunch of bird jokes because I've studied birds in a past and current life. Did I use up all my time yet? Okay. Hey, I'm David. I'm giving a talk tomorrow about modeling the brain with current neural networks, kind of related to some of the transfer learning Rachel Thomas talked about. But my night job is building libraries for automating annotation of vocalizations. So here's a 15-minute talk compressed into 2.5 minutes. I have some collaborators, Yarn Cohen, who has designed this neural network, and a bunch of students that have helped us label data to test it. We use it to automate annotation of vocalizations. Why would you want to do this? Save time. So a lot of people who study vocalizations, it's a big bottleneck for them to label their data. And if you could label all the data, then you could answer questions you can't answer otherwise. So just to give you an idea of what I mean by that, here's a picture of some songbird song made into a spectrogram. You can segment it by looking for threshold crossings of the amplitude and then labeling those segments that you get by looking for those threshold crossings. And you can sit there with a GUI and label to your heart's content, but even if you have enough undergraduates to really scale up the undergraduate algorithm, you'll never label all your song. So in 2017, I gave a talk about hybrid vocal classifier. It's a library that's kind of a wrapper around scikit-learn. Basically, the result that I've gotten with that is you can use these supervised learning methods like support vector machine, but you can always do better with just a simple convolutional neural network. And they all rely on being able to segment your song well, or your whatever vocalization you're studying. So if you have some noise in your experiment, like I'm showing you here, then you're not going to be able to get those features out that you would give to your support vector machine or whatever your algorithm is anyways. So you need something that can do the segmentation and the predictions of labels for you. So my collaborator just designed this neural network, TweetyNet, that does both those things. And to try to make it easy for everyone to use that, we have this library Voc, like Vox voice, that tries to take in all your data and give it to neural networks. And then because people use a bunch of different formats to annotate their data, Crozetta, yes, there's a pun in the name of the library in the talk, thank you. That tries to make all these different formats interoperable and let you work with them easily. So TweetyNet, I can't go into the details of this architecture. It's convolutional and recurrent. If you don't know what that means, you want to know, come find me. Basically, it spits out a prediction for every time bin in your spectrogram, and then you can recover the segments from that. And here I'm showing you that it generalizes well across individuals, and also that it outcompetes some other network with much less training data. And works on other species.
And thank you, David.
Yeah. Then come check out my libraries and tell me if you care about that stuff. Thanks, everybody.
Up next, we have Thomas Fan. And is Taha in the room? All right. So instead, on deck, we'll have Leo Wasser. And after that, the next person on Paul's list. Catherine Gosmeyer.
Awesome. Really glad that you could improve the accuracy with convolutional networks.
All right.
That was a pro pun. That was a pro pun.
I'm also really glad the GitHub link was there because it's important to have a vocalization localization.
All right. Thomas? I'm on the clock. I'm on the clock. All right. How many people use scikit-learn? How many people know what column transformer is? See, Andreas? I mean, if you're here. All right, a column transformer is experimental for quite a bit. And how do users know it's experimental? In our doc string, right? People read our doc strings, right? Right there, it says so. And in the latest release, it's not experimental anymore. And how do you know that? Because we removed that line. Ooh, right? So recently we had experimental features and we implemented it in a different way. So is there a better way? Yeah. If you want to use the new history gradient boosting classifier, we have an import statement you could use, and it'll just enable the experimental feature so that your users will know they're dealing with an experimental feature. All right? It's very cool. You should also use this classifier. It's really cool. Now, the cool thing about this is that when you upgrade to the newer version of scikit-learn, it still works. So the first statement would just be a no-op. It does nothing. All right? So what if you want to implement this yourself? Like, this must be crazy, right? This is like we did some crazy monkey patching, and no, we didn't actually do monkey patching. All the code, it fits in one slide. All right? This slide. It's just, that's kind of weird. All right, it's kind of shaded in the top. It imports the classifier. This is better. Imports the history gradient boosting classifiers, and then it puts it into the ensemble namespace, and that's all you do. All right. If you want to enable experimental for your library with this flag type deal, this is all you do. All right. Okay, so what kind of features are experimental in scikit-learn? These two things, use them, test them. We put them as experimental so that we have users try them out, and we're iterating over them quite quickly. So try them, see how they work. If you have an issue, put it on an issue board. That's it, 2.5 minutes. Yeah.
Yeah, I'm really glad to have that column transformer now. I mean, I've been dealing with Dorian forever, and I'm ready to get to the Corinthian ones.
Yeah. That was great.
Wait, hold,
Up next on
wait, hold on. Is that all there was to it?
Up next on deck is Suhail. Probably mispronouncing it. Yes, no. Suhail, there we are. Oh. Gil's correcting me. All right, take it away.
Sweet. One sec. Not sharing.
You are.
Okay. Good afternoon. So I'm Leah. I work at Earth Lab in University of Colorado Boulder, and I'm here to talk to you guys about PyOpenSci. So this is Bob. Bob's having a really bad hair day. And you might be wondering why. Well, he's got a ton of data to process, and he doesn't know how to do that. So he goes out and figures out, he writes some code, he gets his data processed, gets his project done, but it would be pretty awesome if he could share that work with someone else. But the problem with that and why he's having such a bad hair day is that his code's a little bit messy. So it's kind of like Bob is a child that tried to build a house with a hatchet, and he went to Instagram and got a picture of a house, and that's how he built his house. It wasn't pretty, it looked like a house, but no one wants to live there. So imagine Bob knows how to find the tools that he needs to work on his data and process it, but even better, Bob can contribute to other projects that are doing the same kind of thing that Bob's doing. That would be pretty awesome. So who in here has heard of ROpenSci? Raise your hands, please. Sweet. So PyOpenSci is modeled after ROpenSci. We are a community that values open science and reusable software. 3 goals. First, define best practices for Python scientific software for people like Bob that are doing this work. Second, peer review of these packages that adhere to those standards. And then finally, education associated with contributing back to open source software. So here's how it works. You submit a package to PyOpenSci, the community reviews that package, it becomes accepted and part of the PyOpenSci ecosystem. Now people like Bob can find your package. It's not just a thing on GitHub somewhere. And there's education surrounding everyone contributing more to open source software. And this, at the end of the day, leads to better science. So PyOpenSci is supported by an army of penguins. I'm just kidding. Penguins are really, really hard to work with. So we actually want awesome humans like you guys to work with us as volunteers, as reviewers, as editors, as collaborators. And speaking of awesome people, we've got a great group already on board. And if you want to learn more about us, you can go to our website, or you can join us at 6 p.m. after the session in room 204. Look forward to meeting you guys. Thank you.
Well, thanks for puffing up that effort there. Up next on deck is Daniel Chen.
There was a waddle of groans to that pun.
I'm downvoting you.
Hi, I'm Catherine Gossmeyer. I primarily studied astrophysics for my bachelor's. I have since worked for 3 NASA missions as a developer and analyst, and I'm a part-time graduate student in GIS. For the last almost 2 years, I have worked for NASA's ISAT-2 mission, which is a laser altimeter, which takes advantage of the fact that the speed of light is finite. So that means if you can measure the round-trip time of your light, you can derive the altitude. So you can just think of it as a stopwatch in space. This stopwatch was, the programming behind it is all in Fortran. And it outputs an H5 file, which is used to build on all the science products. Mission requirements tell us that we need to be measuring altitudes and the precision of centimeters, which means we need to be actually measuring light in the time of flight in picoseconds. So how do we know this Fortran code implemented this recipe book correctly? That task fell to me to verify this product. So I decided to rewrite it in Python. And because I don't have to be so formal, I decided I don't want to do H5. I just want to pickle all of my calculation objects. So my talk really is about pickles. If you go on Stack Overflow, people will tell you never use pickles. But if I listened to people, then I would never have done this. It actually made everything really, really easy in my use case, and I'm here to convince you that you should use it too. It retained all my types. I had access to all my variables, my calibration selections, all my intermediate equations. I didn't have to think about what I needed to write out. It was all there. I didn't have to deal with read and write errors. I could save all the intermediate stages of my long computations in separate pickles. So it was great for making a change and then testing it. So in summary, Stack Overflow does not tell you that pickles are great for testing and quick looking and for saving your intermediate stages. And Stack Overflow is very happy to tell you that it's not great for storing your results long term. It's not great for sharing with all your friends. But I also need to quickly plug the Astrophysics source code library. I have been an editor for it for about 3 months. It's actually 20 years old. It has over 2,000 astrophysics codes indexed. Its goal is to make astrophysics and planetary science codes that are used in published research citable and discoverable so that you get the credit for what you did. So if you want to submit your code, you can go to ascl.net/submissions. We also have a Twitter feed that has a random code of the day. And you can find me later for some ASCL swag. I also have APOD swag because they happen to have the same founders. So thank you.
Thank you very much. I'm surprised that you rewrote it in Python, given that Fortran is a go-to language for this sort of analysis.
I appreciate that she showed us. I appreciate that she showed us what the dill was.
And I'd say that Stack Overflow post left a sour taste in her mouth about the pickles.
Half sour, really. The next on deck is Melissa. So.
But you've already got to applaud her for ignoring her friends and listening to her own brine.
Am I up? Okay. Oof. That's assault and battery. All right. I'm going to talk about finding pathology in brain images. I'm Suhail Anadi. My day job is a data scientist at Capital One. I trained in physics, and I spent most of my career in academia, working on MRI and neuroscience. And then I had a midlife crisis and, decided to go to the dark side. But Capital One is actually not the dark side. So anyway, if you want to talk about my day job or transitions from academia to industry or midlife crises, or if you're interested in doing a postdoc with my collaborators or doing some training at the NIH, talk to me. So this is a collaboration between me and my hobby life and the NIH NINDS, epilepsy group. So Sarah Nutty is the neurologist, and Katie Snyder and Emily Whitehead are two research assistants in her lab who did most of the work of the data collection and analysis, and then another neurologist, Bill Theodore, and a neurosurgeon. So what is epilepsy? Brain disease, lightning strikes in your brain. It's a network disorder. So if you have a small pathology, the network is disrupted. It's a very heterogeneous disease. It's often a focal starting point, but then has longer range network effects. It's pretty common as far as neurologic diseases go. It's like the third most common. About 1% of the population has it, so you probably know somebody who has it. About 30% of the people don't respond to medication. And surgery is a great treatment for it if you can find the source of the seizures. And so the way that works is you do a bunch of non-invasive testing. Sometimes you can roughly tell based on the seizure, the way it expresses itself in the person. Other times you can't, and then you have to stick electrodes in the brain. That's scary. Where do you put them? Often you can't see them on regular MRI. And even when you do, like in this patient, if you don't put the electrode in the right place, it looks like the seizure came from both sides of the brain. But if you put the electrode in the right place, you can see where it started, and you can use a really cool thing to find where to put them. We tested this on 12 patients. This is the first time I've seen an AUC of 1. This won't hold up as we have more patients, but it's freaking amazing. So you take some features. This is a cool trick. If you can get yourself into a latent representation, any way you can, variational autoencoders, whatever, Gaussianize, and then you can project onto interesting directions. Then you can compare your individual patient to the normative population and get some really cool models. 4, 3, 2, 1.
Time's up. We need to seize your mic.
Thank you. Up next, Mike Kern. I miss it.
Seize your mic.
Seize your mic. How's everybody doing today? Woo! All right. Welcome to your second day. Oh, did we do that part already? No, I don't think we did. We just launched into it.
Can we do
Oh, is it? Thunderous applause for the audience. For the lightning talk. Hello.
All right. Yeah. So I'm short. Hi, my name is Melissa, and I'm chair of diversity for this year's SciPy, which I'm really happy about. This is my second SciPy, and already I'm doing this, so I'm a little intimidated, but I'm so happy to be here in front of you all at this time. And I'm here to talk a little about some of the data that we have for this year. So we've had a 10% increase in attendees from last year, which is amazing. We have full capacity, I'm told, and so this is great. And from 2017 and 2018, we've had people from the US and 10 other countries. And this year, we have people from the US and 33 other countries, which I think is great. Which I think is great also because there's a higher diversity of people who don't speak English as a first language, and I feel a little less self-conscious about speaking in English to all of you right now, so excuse me. I come from Brazil, and anyway, We've had attendees identifying as female, non-binary, third gender, or gender not listed increased in 12%, which is also super nice. And we've had about 22% of participants who did not fill out our survey, the survey that we send when you register for SciPy. And for those of you who like graphs, I've done a graph, so I've had a plot of this, so you can see the year-over-year increase in the attendees. So you can see that this is improving, but we've had a lot of questions about this because it is difficult to quantify this kind of data, especially because many people don't answer the survey, and because it is delicate how to phrase those questions in a way that is safe, that is inclusive, and that we can gather real information from people. So we are going to discuss these issues at the Diversity BOF tomorrow. So if you want to come around and see, if you have ideas for improving this, you can come and discuss it with us. Celia Sintas is going to be the moderator, and I think it's going to be really great. So the main issues that we want to take care of here are like ethics of who is going to deal with the data that we collect, if we want to collect data, which data do we want to collect, how do we want to phrase these questions, how do we make sure that everybody is included, and how do we protect this data so that it is safe, and people handling this data know that this is important, it has to be anonymized. I mean, all the issues around data, right? So thank you so much. I'm really glad to be here, and I hope more people come to especially newcomers, come and speak at the lightning talks. Thank you.
Up next, we have Chris Osterchuk. Chris, are you here? There you are. No, nothing from the pun gallery?
Crickets?
The pun gallery?
Oh, yay. Okay, cool. Hi, everyone. My name is Daniel. I am not Eric, for those of you out in the field. So, has anyone read this paper, or who knows about this paper? It is by William Noble, and he talks about, in this paper, one way to set up your computational projects, right? And I'm a data scientist, I can adapt this to what I need. So every time I'm working on a data science project, I have some kind of folder structure. So I don't have a single folder of like 300 files, and I have no idea like where's the entry point for my analysis, et cetera, et cetera. When I was working in my former research lab, we sort of had a structure like this. So we have our data folder, we had project data, and we split our data into original, working, or final, just so we're not touching the raw data sets. Everything's always done by code. We have code in a special SRC folder or something. Things like figures are in output, et cetera. Sometimes you have a make file, there's a git ignore file somewhere. At the time, I was mainly an R user, so there's an R project file, et cetera, et cetera. And I'm here to say that like R is great. R solved this problem when you are working with folder structures and you're trying to like map to a data set, and your working directory sometimes, depending on where you are, is like always changing. And so R has this library called rprojroot that essentially quote unquote finds the project root directory for you. And they wrote a higher level wrapper around it called here, and what you can specify in here is the name of a file, and it'll give you the entire path of that file based off of where your project directory is. So, since Python is great and all, I yesterday decided to port roughly like those bare components into Python. So there's a project called PyPodRoot. You can, why is there noise going on? Okay. Anyway, someone's laptop is singing. But you can pip install this. And just as a demo. Whose laptop is this? So you can pip install this. This is what it looks like in a Jupyter notebook. So you can import the here function. You can load up, for example, a pandas data set, and just to show you guys, here's the current working directory. I'm in from my tutorial, I'm in my tutorial in a notebooks folder, because Jupyter notebooks like to change the working directory without telling you. So here's the current contents of my file, a bunch of notebooks, but usually what you have to do is read CSV ... /data, right? So those are all my data sets. But with the here package or library, you can now just say here and then all mention or list your data sets from your root directory. So you don't have to go find the project root. You don't have to have ... // everywhere. You can move your notebooks around and you'll be able to find your data sets. So.
Thank you, Daniel. Now,
Eric?
No. So for those of you who don't know, that's Daniel Chen. He's frequently confused with Eric Ma. And what we need is some sort of classifier that will, and to do that, we need to do some Ma-Chen learning. Thank you, thank you. That laptop was playing something called Chill Up, chill and lo-fi hip hop music. So if that, it's a Windows machine. If that is yours, then come. Otherwise, we may raise some money for SciPy.
Seems like it is. Daniel, thanks for solving the root of the problem.
Here, here.
Okay. Okay, two things. One, I apologize in advance for giving these guys so much material, potentially. So number two, so there were 2 earthquakes last week. How many people, a show of hands, experienced those earthquakes? Okay, not a lot of people from the LA area. That's interesting. Okay, so who am I? I'm a software developer, not a seismologist at the National Earthquake Information Center. Why am I not a seismologist? Why isn't a seismologist giving this talk? Well, they're not here, so you get me instead. So I develop mostly applications that deal with earthquake impact, so not the location of earthquakes, but the human impact of them. This is where earthquake hazards are in North America, generally speaking. This is where my office is. This is not an accident. Okay, so what happened? So last Thursday on July 4th at about 10:30 in the morning, there was a magnitude 6.4, and our models estimate that there were about 2,000 people exposed to severe shaking, so which is an intensity 8. And then from news sources, we learned that there are minor injuries and no fatalities, thankfully. So then the next day, on July 5th, at about 8:20 in the evening, there was a magnitude 7.1, and there were 45,000 people exposed to very strong shaking, which is 1 intensity level down. Again, minor injuries, no fatalities, and the cumulative damage from both of these earthquakes, we had toppled chimneys and buildings damaged or destroyed, roads cracked, gas leaks, fires. All of this information is from news sources. And then aftershocks, in the week since the earthquake, so I just generated this plot this afternoon, so there have been 10,000 aftershocks in the surrounding region, and that's this map here on the right, and magnitudes ranging from a magnitude 0.3 to 5.6, not including the foreshock and the main shock. And so the question is, could this have been worse? Yes, so here's the epicenter, so out in the desert, approximately 120 miles or so northwest of LA. And there's Los Angeles, a city of 13 million people. So location matters a lot with earthquake losses and fatalities. So the next question is, how can you learn more about this? So you can go to our website and look for the list, so this is earthquake.usgs.gov. Look for the list of significant earthquakes. These are global, so we don't just do earthquakes in the US. Click on the earthquake you're interested in. For each earthquake, we have a number of information products. And so for the human impacts, you click on the pager link, and then the Python shout out here is that the bottom 3 are all Python products. And then this is the pager link, so we provide estimates of ground shaking, fatalities, losses. Also read the news, journalists do a very good job of estimating, or of reporting this stuff. That's it. Thank you.
Thank you, Mike.
I have to say, that lightning talk was really shocking.
Well, I used to live in California, and I'm really moved by that presentation. I'm just shook.
Yeah, I'm from Missouri, so we have the New Madrid there, but I can just assure you that this one was not my fault.
I'm still shaking from that last one.
We're under a lot of pressure. The next up is Julia, and then also on deck is
Ardeshir?
Yes, no.
Are you sure? Are you here?
Oh, yeah, there we are.
All right.
Thanks. Take it away, Chris.
All right. Hi, my name is Chris Ostrakov, and I'm a scientific software developer at Quansight. And what I'm going to talk a little bit about is understanding how packages are being written by developers. So at Quansight, we have several package maintainers, and oftentimes a question comes up is, can I depreciate this function? How are users using my packages in tests versus in source code versus in notebooks? Maybe also like what material belongs in a tutorial based on what's used most often. Another contentious issue that's going on right now, PEP 594, removing some modules from the standard library and moving it out to, say, SciPy. But so far, when I've been looking in this whole discussion, there haven't been any quantitative like data on how these modules are actually being used. So I wanted to help educate this discussion, and also just to be able to allow users to be able to ask their own questions. So how did I do this? The first step is I use libraries.io, which assembles all the packages that depend on a given Python package, NumPy package, you name it, or NPM. So in this example, we have NumPy, and it lists 70,000 packages that depend on that. So what I did here is I took 4,000 packages from about 20 different popular Python packages, and I downloaded all the source code on GitHub. Then the next thing I did is I used the Python AST module to parse all of the source code in the .py and IPython notebook files, and I generated a SQLite database of all of the functions that have been used, all the attributes, and a lot more properties. And also I can account for interesting like import, as, and renaming and stuff. So then finally, I used a really awesome library called Dataset, and it allows you to expose a SQLite database as a read-only REST API. And you can use SQL queries to arbitrarily ask your own questions. So in this case here, I'm just asking how many distinct Python namespaces do I have? Here I have 56,000. So here are just some questions that can be asked, but I'm just going to pop you to the actual repository. So if you go to this GitHub repo, you can ask what is the top 100 most used standard library module functions. And here we can see os.path.join is the most popular one. Other interesting questions, we can look at what are the least and most used standard library modules. Here we see OS is the most used, but you can formulate your own queries. So let's go really quick with NumPy. And NumPy.newAxis is the most popular attribute. Let's look at functions of pandas. No surprise, data frame shows up because it's a call. But here we can just quickly change this to, say, let's do RE. And we'll see if the query finishes by there. Okay, so this is the most popular RE function.
And thank you, Chris.
It was a nice first talk. I was wondering if you could have a sequel.
Very nice, packaged a lot of content into 3 minutes.
I prefer my data sets to be awake rather than at rest. But, oh yeah, and then up next on deck we have Henry. I can't make out your last name.
Yeah, Henry's talking about PyData Weaver. Where?
Oh, Henry, there we are. Great, perfect.
Excellent handwriting, Henry.
All right, so my name is Julia Signal. I work at Anaconda. I'm here to talk about Intake today. So Intake is a library that will help you read your data. If all my demos fail, just take that away. If you have data, you should think about using Intake. So its intention is to take all the pain out of data access and distribution. So if you have notebooks where the first cell is just 6 lines of how to read your data, Intake can help with that. How Intake does that is you write catalogs, often in YAML. These are all the different file formats that are currently supported. And it's very easy to use the plugin system to write new plugins for whatever file format you are using. So now I will show you how it works. You can just do import intake.
Font size.
Font size. Is that better?
Enhance.
On screen.
More?
More.
All right.
More.
I don't know if I have more in this one, but okay.
Less is more.
I have a notebook too. We'll do that in a sec. So you can just use the built-in catalog. You can install packages that are data packages that you've created and uploaded to anaconda.org or wherever. And then you can do things like this. Not like that. And you can read the metadata, and then you can also read in your data itself, just in one line. So that makes it really easy. You can distribute your data. And then here is a more involved one in a notebook, bigger, or is that okay? All right, okay. Same one, and we're reading in the data, and we're plotting directly from your intake data source using hvplot, but you don't have to. And then here is reading from a catalog that is hosted online, and it's Anaconda package data. And I'll just show you that you can read it to Dask. You can also read it straight to Pandas. I'll skip that part, and I'll show you what a catalog looks like. This is a more involved catalog where we're defining different inputs that you will declare. So you can get just a chunk of your data that you're interested in. It uses this Jinja template style. The plugin directory I showed you. And if you want to try this out yourself, you can go to intake examples, and there's binder links. You can look at it and play around with it and check it out and talk to us. There's a bunch of people here who use intake.
Thank you, Julia. Oh, I actually forgot who the next person is. Go.
Boy, that looks great. I hope it gets a lot of uptake.
I don't mind going next either.
The live demo was really impressive, also a little exhausting.
Next is Matthew, again with the last name. Just shout or wave or jump. Weicker, maybe? Fiker? Okay, not here. So up next, after that is Sophia Hooper. Oh, there. All right, okay, perfect. So, all right, thank you. Calvin.
Ready? Cool. Hey everyone, my name is Artish Baheshti, also go by Artie. Spatial decisions are not always easy. So the purpose of this project is kind of to introduce, so I'm a geospatial developer. I'm also a really big fan of video games, and I figured what's like the best way to integrate the two is applying both the things I love doing. So I'm not sure why I made myself come up here, but I kind of want to talk about it and see who else likes that kind of stuff. So background about the game that I did this project on, it's called League of Legends. It's based off of a pre-existing game called Dota, Defense of the Ancients. It's a multiplayer online battle arena game. Those are the two developers at the top. They actually named some of their nicknames as items in the game. It's a two-split team, usually 5v5 or 3v3. They start on opposing ends, which is the red and blue circles. And basically the object of the game is to, throughout laning, which is these 5 rows as you can kind of see, you know, there's a river path, and those little intricate paths in the center is what's called the jungle, which is a specific role for these players. And then the 3 rows as they go along are the lanes that people are fighting in. So what I really want to understand is, someone who plays this game quite a bit, is to kind of understand like my mistakes that happen in the game and also develop a sort of analytical tool that I could show to other developers as well, people who play the game. So it was something that I kind of developed some time ago, and I wanted to kind of show again because, again, I wanted to see if anyone else was interested. So these are just a set of functions that I made and API keys and everything that's kind of calling all these tools. And basically what I wanted to figure out is the amount of deaths and kills, I guess, so to say, are happening throughout the game. And so what I did is I took a sample data set of 200 beginner players and 200 players who are considered professionals at the game at a high level. And by doing so, I got a density breakdown in a span of 10-minute increments. And for this, it kind of explained that, so if we're starting from the top of the 5 to 10 minute markers, it shows that, a lot of the focus for professional players and beginner players kind of didn't really change much. It more came down to the 25-minute marker, where those denser plots on the challenger side are where heavier objective focus is placed, and that's where, a lot of, big influences happen that dictated the rest of the game. And so, that all being said, this was kind of the work I did. If anyone thinks that's really cool and also likes to do that, I also do a lot of social media analytics and game development. And yeah, thank you for listening.
Thank you. Henry, come on up. And then up next, on deck, we have Hannah, I believe. So, yep. And yeah, come on. Now, it helps us. It really does. Yeah. I think that version 2 of that game is probably called United Legends. No? Yes. League of Nations, United. Yeah, all right. It was an A to Q or something kind of joke, but too soon? Too soon? Too soon for a league?
Which one are you
Anthony,
supposed to use?
you did Wilson.
What?
Which one are you supposed to use?
It's this one. Yeah, just keep making World War I jokes. It's totally topical. We still have a ThinkPad, by the way. And chill hop. All right, thank you, Henry. It should be popping up.
Hello, my name is Henry, and I'm a software developer at the Wildlife and Ecology Department at University of Florida. I am introducing PyData Weaver. It's a data integration platform. It helps us to actually reduce the time we use to integrate data, because most of the time we think that when it comes to research, we need a comprehensive data set. And the way we get it is by integrating individual data sets that are collected by different scientists. It requires public data. It uses one of the tools that we have developed in-house. It's called the data retriever. This integrates, cleans up the data for you, and installs it into various dataset management systems. The PyData retriever, the PyData Weaver uses Postgres because mainly it's integrating spatial data, not only tabular data, but spatial data. It integrates this data and creates a very clean, comprehensive data set for you. And some of the commands that we use, both tools are on, you can install them using pip. You can install the PyData retriever, and you can search the data sets that are in there. These are plugins that have been built based on a schema or a JSON data format that we have adopted or created, and it comes from the frictionless data group. And you could try some of the examples. And this is a group of team that has helped us to create these tools. And you can find this tool here. Thank you very much.
Thank you, Henry. That work sure looms large. So what if I make some puns?
Super helpful contribution to the fabric of the open source community.
Yeah, there we go. Double man. All right. Do we have time for one more, Paul? Let's do it. Who's up next? Who's on first? Yeah. the microphone. We really need
Can't
another
see.
microphone.
Is that?
Sophia Hooper, are you here and ready?
All right, thank you. Come on up and, Sophia.
This is not working. Why is this not working? Oh, crap.
I've said it before, but year of the Linux desktop.
Yeah.
No, I think that's an original, Anthony. You've never said that before.
Given this isn't working, maybe Sophia should go.
Or Hannah.
Or Hannah.
Hannah's next.
Okay. And I can try and solve this later. My bad.
Okay.
Hannah, go ahead.
Oh,
Hannah
yeah,
said
something flickered, but Hannah come up just in case.
Hannah, come up.
All right. Can get you first up tomorrow.
I think I know why you're repeating yourself. I think like it's time for you to retire. You start to have Alzheimer.
I didn't understand a word you said.
It's because you're old, you can't hear.
That's right.
You need to retire.
Kids these days.
Did I mention Anthony's been doing this for 10 years?
Okay.
10 years.
My laptop's being
He's got tenure. Well done, Matt. Well done.
Guys.
There you are.
You all see it? Wait, y'all? How many of y'all do everything last minute? Super last minute?
Yes.
Wait, you're gonna all help me finish my slides. So, we're gonna use Jupyter Notebook, because why not? And we're gonna use the live markdown preview here. Title. Categorical, can't spell, really. Color, tweet handle. Right? Okay, do I need anything else on a title?
No.
Nope, great, score. Now I need my image, my introduction. Don't quite like this one. So, let's change it out. And set, great. What else do I need? Oh, let's convert this. Let's turn this into a slide. Code, too small? Way too small. Great. We're going to use the plugin that makes our code bigger. Bigger, bigger, bigger. Cool. Okay, finish my slides. Let's run. Okay. Category color, my field, my love. And first thing, what are categories, right? Beginner, intermediate, advanced. Categories are any type of qualitative data where we can bin it into discrete groups. And these are actually the levels for the sprints. So if you're thinking too advanced for me, most of the sprints, they're for you. Seriously, go. How many of you are going to go? Awesome. Code, the cool part matplotlib is now, how many of you hate labeling bar charts in matplotlib because you have to renumber? How many of you knew that you don't have to renumber anymore? Yeah, we do. We support strings as first-class data objects in our plotting methods now, and have for like 3 years. So,
You're welcome.
so, yeah, you can just put in your titles directly, put in your values, and it makes, actually, makes this. And if you want to talk more about data types, not just support, oh, sorry. What's next? We're going to try to make it categorical color more customized, more, you can set our order. We want better categorical color mapping. We want, you can plot a satellite missing code and it'll show up. And we really want better support for accessibility. So Matthew Petrov has this fantastic color cycle survey. All of you, take a picture now and take that survey, okay? How many of you are going to help make better colorblind maps? Great. So take that survey. He's building out a whole research on what kind of color maps are going to be more categorical color maps are more colorblind friendly. Because by categoricals, we have a limited set of colors that are visually distinct enough to be seen. I'm going to get shoved off soon. So if you want to talk more about data types, not just strings, complex types, extension types, IPs, addresses, everything, come to my booth. Thank you. Woo!
And we left the laptop.
Of course I did.
Thanks to the Matplotlib developers for raising the bar.
I heard a hissed. No? All right, and last up for the day, we're going to have Kevin come up and give a talk that he's never given before.
Yes.
Other way. All right.
Yay.
I do like silence.
Okay.
Bigger, please.
Okay, my name is Sophia. I work for Conda. I'd like to introduce you the Conda package download data if you don't know it already. So back in March this year, we published summarized Conda package download data for the Anaconda distribution channel, as well as the popular Conda Forge and BioConda channel. Our data format is Parquet files, 1 file per day, and they're hosted on S3, free to users. Anaconda is paying for all the costs. And here I'm going to show you an example of how to use our data. You can just click the binder. I already clicked it and run it already. Okay, so there are 3 ways to load our data. You can load it directly from a S3 URL showing here, or you can load it from an intake catalog. Julia just showed you this catalog in detail. So you would define the URL of this catalog and specify the year and the month, and then you can load it to our DAS data frame, or you can load it to a pandas data frame if you don't specify this to DAS method. Third, you can load our data from a Conda package by running the Conda install commands, and then just specify the year and the month directly. So what you can do with this data, you can, if you have a package, you can just run this command and see how many downloads you have per day for a given month or a given year. We can compare Python 3 versus Python 2 versus Python 3 usage. And here's an example for December 2018. We see a lot of Python 3 usage, but not a lot Python 2 usage. And you can also look into different platforms and compare different platforms with our data. So you can actually answer a lot of questions with our package. Hope you find it useful. Thank you.
It's always fun to see how Conda is used in production. Conda Pro, no? Yeah, it's really. I'll get off the stage in a moment.
That was just bouquet. I've made that one before too, so.
Just, I want to really thanks to Kevin, because he's going to give a talk. He hasn't seen the slides yet. So it's going to be a blind lightning talk. You know roughly the subject, so please, big round of applause for him. And he's presenting from Paul laptop, which is Linux, so again, year of the Linux desktop.
Are these on?
They're on. You're live.
All right. It's all you.
Oh. Okay, so my name's Kevin Winters, second time SciPy, first time lightning talk. And I'm going to talk to you about something personal, a personal issue that is near and dear to my soul. My choice of footwear. Yesterday, 2 gentlemen asked for a picture of my toe shoes. Interest in my shoes is kind of typical, especially in elevators when everyone is looking down at their feet. The topic comes up. But after the photo shoot, they went and took a picture of my neighbor, and I thought, wait, what's going on here? This is strange. Usually the attention is on my feet, my shoes, not other people. So I'm here to present the results of a Python-based experiment laced with tongue and leather comments. And by the way, I was not involved in the data processing, I haven't seen the slides, and I was not given a boot camp. So enough with the general arch, let's look at the kicks. So how do you recognize the applied mathematician? They're the ones that are looking at your shoes. That also applies for engineers. I am a civil engineer by academia. So why are we always so serious, I guess? We need to have some fun. So we're going to use the scientific process, and sure enough, we collected a lot of data, we analyzed data, and we asked some questions. Later. We will ask questions later.
So, recommend to watch this lightning talk later.
This is just the origin story of how this lightning talk came to be.
Okay.
Is this yours or Kevin's?
Do I need to play this? I'm going to...
No, just go.
Okay.
No.
So, apparently Peter Wang of Anaconda.
This was a 15-minute lightning talk in 2010.
Okay, we're skipping
Another one
that.
to watch later.
Thank you. Okay. We're getting through this. By the way, people were asked, can I take a picture of your shoes? So some of you have graciously subjected yourself and your feet. They are now famous as they are being shown in the corner here. And I am famous around my organization for wearing these fancy toe separating apparatus. Well, wait, they have those creepy individual toes. And yes, when I wear regular shoes, I wear toe socks. They can't touch. I'm sorry. Qualitative results from memory. Okay? First reaction, sure. Wait, are we not dealing with actual pictures?
This is to the question of whether or not we can take a picture of your shoes.
Okay. Second reaction, why? I get that a lot with my toe shoes. Okay, most people accept before knowing why. Like myself, I'm up here, why? Quantitative results, okay.
Obtained via neural network.
113 people. Very nice, thank you everyone. We had shoes and feet and legs in 112, so that's a good majority. Pictures with only shoes, 1. I wonder where they were wearing those shoes. Of pictures with 2 shoes, 99. So thank you for whoever's missing a shoe.
Several people.
Pictures with 1 shoe, 12. Let's see. I'm an outlier. Closed shoes.
Closed-toed shoes, sorry, that's
Okay.
a typo.
That's the majority of
You should
normal
really check your
people.
slides before you present, Kevin. It's kind of an amateur move.
Open shoes, 18. So those who like to have your toes breathe, good for you. What else do we have? Okay, neural network. We went through Anthony's brain, or the fake brain of the neural network, inequality of underrepresented groups and core project leadership talks. So that's it. Reminder, there was a Google phone involved and a Google Fi plan. And they upload to Google Photo. Okay, so these are now on the cloud. Dozens of feet, shoes, pictures. Whew, we're gonna be famous, guys. Someone's gonna have a shoe fetish. In mail folder morning after, okay. So, who is reviewing what our communication? Remember, if you're not paying for it, you're the product. Thanks to me, but more importantly, thanks for all of you guys for putting your shoes out there on the web.
Thank you, Kevin. All right. Please stand up if you had your shoes collected.
Oh.
All right.
By the way, one last thing, just to remind you guys, Python can do amazing feats.
And with that, we're closing out the lightning talks.
We'll see you again tomorrow. Have fun at your BOF.